ready ready.
Ready? Hello students, welcome to ACE Engineering Academy, and here we are going to discuss about an ACE ISRO series, Indian Space Research Organization. ISRO given a notification for scientist posts, and that notification has already come. As part of that ISRO series, we, ACE Engineering Academy, and powered by ACE Online, are running a revision series for the preparation of ISRO for ISRO aspirants. Here, myself, Ramesh Masuna. In this session, I am going to take about compiler design. In ISRO, what are the questions were asked, and what is the weightage analysis, and what are the topics on which you have to focus. Those all things we are going to discuss here, right? Fine. Very first, we will understand what is the syllabus for compiler design. The syllabus for compiler design consisting of lexical analysis, parsing, syntax-directed translation, intermediate code generation, code optimization, and code generation. These are the 6 topics of a compiler. Now here, these are the 6 topics of a compiler. Happened. 1 minute. Yeah. These are the 6 topics of a compiler. Among these 6 topics, when you see the previous paper analysis, I have analyzed previous papers from 2007 onwards. When I have seen the previous papers from 2007 onwards, from the first chapter, second chapter, and the last but one chapter, code optimization. So far, whatever the questions were asked from the compiler design is from lexical analysis chapter, parsing, and code optimization chapter. And so far, no questions are asked from syntax-directed translation, intermediate code generation, and code generation. Okay. But in ISRO, it is mentioned compiler design is a subject. In compiler design, these are also the topics. And because most of the questions that were appeared in the previous ISRO papers are the previous GATE questions, most of them. Because in GATE syllabus, syntax-directed translation is important topic. So many questions were asked from syntax-directed translation. So far not asked, but it is possible to be asked. That's why I suggested you, please focus in these other 3 topics also, right? Syntax-directed translation, intermediate code generation, and target code generation. At least you refer the previous year GATE questions. In that, especially 1 mark questions, you refer it. Because the standard of ISRO is bit below than the GATE. Suppose you are a GATE aspirant, you can easily crack ISRO exam. Fine. Very first, we'll go ahead with weightage analysis. Means in which topic, how many questions were asked. From the first topic, like the basics of compilers, introduction, and lexical analysis chapter, there are 11 questions were asked so far from 2007 to 2020. These papers. From parsing chapter, there were 16 questions were asked so far. And from the code optimization, there are 8 questions. So far, I have recognized these questions from the 2007 to 2020 papers, and total of 35 questions. There are total of 35 questions were asked. Okay, 35 is lesser in number, but definitely 35 is lesser in number, but definitely each question will have its own weightage. So each question will make you forward towards the space scientist. Correct. So every question is important, and whatever the questions that were asked from the compiler design, also very basic level questions. If you have a theoretical knowledge, that is sufficient. That's why don't ignore it, because every mark is very precious that will take you towards the space scientist. Are you an ambitious to become a space scientist? Yes, of course. So please focus on this lecture, and here I'm going to discuss the basics of compilers in the today's session along with the previous questions. Why? Because there are only few questions were there among all the topics. So instead of taking a particular topic and discuss, so I thought better I discuss overall the complete compiler design subject along with a little introduction. Okay, chalo. Very first, we'll go ahead with what is compiler. Just we'll discuss the basics, and then we'll go ahead with almost all the previous year GATE questions. First, we'll go ahead with what is compiler. As you know that every people generally says compiler is one which translates high-level language to machine language. Okay, happy. You gave that definition. I don't say it is wrong. I can say it is right only, but what is the exact definition for the compiler? Instead of saying high-level language to machine language, the accurate, the definition that is satisfied for all the compilers is to say it is a language translator. Why it is called it as a language translator? Because it is translating the source program to target program, because it is a translator. So it is going to take an input, a source program, right? It is going to take input a source program and translates that input into equivalent program in another language called target language. That program is called target language. Now here I use a target language. Then you may be thinking about it, right? Sir, target language is machine language only, na? Okay, target language is machine language only. But machine language is not only the option for the output of a compiler. Let me give. What a compiler is a language translator. What it will take? Input, a source program, and target, output, a target program. As I told you, the target program need not be machine code always. It may be an assembly language program. Why assembly language program? When the era of computers was started, initially people used to write the program in binary bit patterns. Later they use symbolic notations, that is called assembly language. But that symbolic notations is to be converted back to binary bit patterns. So there is a language translator that will take care of the symbolic notations to be translated back to the binary bit patterns, is called assembly language program into machine code. Most of you know that machine code is only one. But actually machine code are of again two types. What are the machine codes? There is a relocatable machine code, and another one is absolute machine code. Then, sir, so far we know machine code only. Sir, what is that absolute and relocatable machine code? Don't worry. So what is relocatable machine code? The name says the machine code is relocatable to where? To the main memory. That machine code is to be relocatable to the main memory for execution. Means whenever the program needs to get executed, where that program should be loaded, the program should be loaded into main memory at some fixed locations. At some fixed locations in the runtime memory. As you know that runtime memory consisting of stack area, static area, heap area. So in the static area, there is a particular memory is allocated for the program code. There is a code area. And in the static area, we have a specific space for global variables, statically declared variables and all. And for the recursion, we use stack area for storing the activation records. For dynamic data structures, we'll use this heap area for storing the dynamic data structures. But when it comes to the program code, it is going to occupy some fixed location in the static part of the main memory. Because it is occupying some fixed locations, then we can call those locations are called absolute addresses. So where it is going, it should go to absolute addresses of the memory. Why? Because whenever a program need to be executed, CPU can communicate only through main memory, not with the secondary memory, correct? Now, suppose my executable code is in the secondary memory. Then I can call that executable code which is there in the secondary memory, I can call relocatable machine code. Why? Because if that executable code to be executed, first it should come into main memory and occupy some fixed locations in the main memory. So means it is going to take absolute addresses. When it comes into the main memory, then it is called absolute machine code. So who will take care the responsibility of loading that source program from secondary memory to main memory? Who is responsible? There is one language processing system called loader. What loader will do? Transfer the contents of data or program that is there in the secondary memory to be loaded into the main memory. That will be taken care by the loader. Suppose if I add that loader functionality also to the compiler, then what is the output of a compiler? Absolute machine code. That's why don't give the definition high level language to machine language. Okay, that is correct. But instead of saying high level language to machine language, we can say source program to target program. Why? Because it is depending on the designer of a compiler. Suppose I am designing my own compiler. I am developing my own programming language. For that I am designing one compiler. It is my choice whether my output of a compiler could be assembly language program or relocatable machine code or absolute machine code. I can take care of it. Suppose I wanted assembly language program. Okay. I wanted relocatable machine code. Assembler features are already developed so that I can add it to the compiler. So the output is relocatable machine code. Suppose I wanted absolute machine code. I will add loader features also to my compiler so that output is absolute machine code. That's why we can say compiler is a language translator which takes input source program and outputs target program. If anyone asks you what are the target programs, you can say there are three types of target programs: assembly language, relocatable machine code, and absolute machine code. Right? Okay. Then you may be thinking about, sir, you told about assembler, loader, and all. Actually, what is happening when you write some code? Maybe you are thinking that, sir, I am writing some code in C programming. So what is happening? How it is converted into executable format? And which is executed? The program that is there in the main memory is executed by the CPU. The program that is there in the main memory, executable code that is there in the main memory is called absolute machine code. Sir, I wrote some program which is in high level language, and actually the CPU that is going to be executing only the absolute machine code. In this two, is only compiler is sufficient? And what is happening? One thing I can definitely explain you. How language is processed. These are basic insights I am giving you, because on basics, multiple questions were there. Actually, the purpose of giving this basic introduction is on basics, many questions were asked. And whatever the program we write is called skeleton source program. Why we call it a skeleton? Because in programming language, we might use many of the pre-processing commands. Let us say we have some pre-processing command, hash define max 20. Now tell me, what is hash define max 20? What is max? We can call max is called a macro. What is the purpose of a macro? Wherever in the program, if we have the macro max, and that is going to be replaced with value 20. That is going to be replaced with the value 20. Fine. So when that is going to be replaced with value 20? Before compilation, not during the compilation. Before compilation. To perform this task before the compilation, again there should be some language translator. That language translator is called preprocessor. What this preprocessor will do? Takes input a skeleton source program that may have a macro processes, and that macro expansion is going to be done. After macro expansion, we can call it as a source program. Fine. And do remember, these preprocessors may not be there for every language. When I'm talking about C programming, we have a preprocessor directives. And this source program will be taken as input to the compiler. And what compiler will do? Translate this source program into assembly language program. Because actual development of compilers were done after the assembler. So assemblers were developed first, later compilers, so that we can reuse the features of assembler in a compiler, so that output of compiler we can generate is assembly language program. But what machine can understand? Is machine can understand assembly language symbolic notations? No. What it can do? It can change this assembly language program into target machine code. That is possible by using assembler. What assembler will do? Translate this assembly language program into a type of machine code we call relocatable machine code. It is called relocatable machine code means this is available as a executable file, which may not be loaded into main memory immediately, which may be loaded into main memory afterwards whenever, wherever I requires. So it is available in some secondary memory, I can say. Let us say it is available in secondary memory. Because if it is to be executed, it should be loaded into the main memory for execution. That's why we can call it as a relocatable machine code. This relocatable machine code is going to be loaded into main memory for execution. It's going to be loaded into main memory for execution. Who is going to load that relocatable machine code into main memory for execution? The program is called loader. And one more thing, suppose many programs requires DLL libraries, we call dynamic linking libraries, or else we can call some other programs also is required. Means this relocatable machine code may require some other relocatable machine codes. So what is required? So this relocatable machine code can be linked with other relocatable machine code by using a program called linker. What linker do? Links this other relocatable machine code with my relocatable machine code to make it a single executable program. And that single executable program to be loaded into main memory by the system program we call loader. So what loader will do? Loads this executable program into main memory for execution so that it is becoming absolute machine code. See here what we are writing? We are writing a skeleton source program. What the system is required? The system requires absolute machine code. In between these two, do we have only compiler? No. Along with compiler, we also have preprocessors, assemblers, linker, loaders. These are the language processing systems. These are called system programs, right? And these programs are together working to convert the program that we have written into the program that is required by the machine. Okay? This is actually the processing system. So when you see the previous ISRO paper questions, as I told you from the introduction, you got something around 11 questions, introduction and lexical analysis phase. In that 11 questions, almost 10 questions are on this basics only. Almost 10 questions on this language processing system only. That's why I thought of discussing this. So what you understand, is it only compiler sufficient? Tell me, is only compiler sufficient? No. In addition with compiler, we also have other programs. But in a compiler design, what exactly we are going to study? How a source program is going to be converted into assembly language program. And in your syllabus, you have preprocessors, compilers, but other than compilers, we have a preprocessor, assemblers, linker, loader. And in the old syllabus of ISRO, there were some few questions based on assemblers also, because actually ISRO follows the gate syllabus. In the previous gate syllabus, we do have assemblers, but in the modified gate syllabus, we don't have assemblers, preprocessors, linkers, loaders. You can see the previous ISRO questions, and that are the old questions before 2010. You can see some questions related to assemblers, linker, loader, but after 2010, if you see it, those questions were not there mostly, right? So this syllabus is compilers. So the questions are possible how a source program is going to be converted into assembly language program. This is a language processing system. Fine. I hope you understood what is compiler, what are the forms of target programs, and what are the other language processing systems. Fine. Yeah. Because very few questions were asked from the compilers, I thought of discussing majority of the ISRO PYQs in the session. Here, have a look. This is a first question. This is based on the lexical analysis chapter, and the question is in 2015 ISRO paper. Just think and answer the question. Think and answer the question. Just I will see in the chat box. You can post your answers in the chat box. I can see your answers. And because you are preparing for the GATE and you are preparing for the ISRO, for you it is, I hope it is very simple for you. Right? Okay, happy. Durga Prasad, C and 10. Yeah, very good. Durga Prasad responded to me. Fine. So the question is the number of tokens. Actually, what is token in C program? The token is called a logical unit of a program, a sequence of characters forming a particular meaning, sequence of characters having some meaning like identifiers, keywords, constants, special characters and all. Now look at here, printf 1 token, open parenthesis 2 tokens, and everything whatever is there in the double quotes is called 1 token, and comma, I, comma, ampersand, I, close parenthesis, semicolon. So totally how many tokens are there? 10 tokens are there. And it is ISRO 2015, and it is also a GATE 2000 question. Same question. That's what I told you very first. So most of the ISRO PYQs are the GATE PYQs. Right? Now, the output of lexical analyzer in 2017. What is the output of lexical analyzer? What lexical analyzer will do? Because in compiler we have 6 phases. What lexical analyzer do is the first phase will take input a source program, output sequence of tokens. We call stream of tokens. Correct? The output is stream of tokens. Very good, Durga Prasad. Keep going. Right. Now look at, this is a question based on the precedence and associativity of the operators. Right? Now what is the answer for this? Only Durga Prasad is there? Right. What is the answer for this question? It is based on the precedence and associativity. Very good. Option D came from one of the student who is watching the live session. So, given the following expression grammar, and this is a grammar given, and question is which of the following is true, and it is a 2015 question. As we know that the operator that is defined with a starting non-terminal, here what is the starting non-terminal? E is having least precedence. Now the least precedence is given to star and plus. And both are defined with a starting non-terminal. Any terminal, any operator that is defined with a starting non-terminal having least precedence, and if more than one operator is defined with starting non-terminal, then between them we have an equal relation. And what is the highest precedence? Highest precedence is there for the minus. Now which of the following is true? Star has higher precedence? No, star has least precedence. It is incorrect. Minus has higher precedence? Yes. Then star, correct. And plus and minus have same precedence? No, plus is least precedence. It is not same precedence. Plus has higher precedence than star. Look, plus and star having higher precedence? No, plus and star are equal precedence. Some student give an answer D, but D is incorrect. And see, it is a 2015 question, it is a GATE 2008 question. That's what I am keep on telling you. Previous ISRO questions mostly are of previous GATE questions. See, when it is asked in 2008, asked in GATE, in 2015 it is used from the GATE. That's what I recommended you, please refer the GATE questions. Now, it is also direct question from GATE. Which of the following statement is wrong? It is also based on the precedence and associativity. Grammar is not ambiguous. Okay, it is unambiguous grammar. It is unambiguous grammar. Priority of plus over star is ensured. Priority of plus over star is ensured. Means plus is greater than star. Correct, na? Because star is defined with a starting non-terminal, least precedence or lowest precedence. This plus is having higher precedence. Correct? So, plus greater than star, yes, correct. This is true, this is true. Right to left evaluation of star and plus happens. Now look, star is defined with S and S is S is right recursive. It means right associative. And plus is defined with T non-terminal and the rightmost symbol in the RHS is same as LHS. It is also right recursion. Right recursion means right associative. So both star and plus is going to be evaluated from right to left, means it is right associative. This is also correct because all the statements are correct. Which is wrong? None of them is a wrong. Correct. Fine. Now look at. So this is very basic question asked in 2020. If you know the basic terminology, like what is grammar, and grammar is defined with 4 tuples V, T, P, S, and V is non-terminals, and non-terminals are represented with capital letters. Non-terminals are represented with capital letters. See, what are the capital letters of these productions? The non-terminal alphabet of the grammar. What are the non-terminals? A, B, C, D, E. That's it. A, B, C, D, E are the non-terminals. Remaining are terminals. Here it is given B, C, D, E, not mentioned A, incorrect. Here it is mentioned terminals also, incorrect. Here mentioned only terminal, incorrect. The question is non-terminals of the grammar, A, B, C, D, E. Very, very basic questions. Look at this question, which variable does not derive a terminal string in the grammar? See, if you use S non-terminal, S is AB, A is deriving A, B is deriving B. Means with S we are going to derive terminal strings. Question is about not deriving, so it is incorrect. With A we are deriving A. This is incorrect. So it is correct, means question is not deriving. With B we are deriving B. This is also possible, but question is not incorrect. And look for option C, capital C. Do you have a capital C production? C. B tends to capital C is there. B tends to capital C. Capital C is a non-terminal, but capital C is not deriving any terminal. So that this is not deriving any terminal. That is an option C. Is it clear? Now look. Which of the following sentences can be generated by the grammar? Here the grammar is given and which sentences are generated? That is a question. Will you answer the question? Very good, very good. The person who is answering is very quickly. Excellent, excellent, Durga Prasad. Right. So happy to see the answers from Durga Prasad. And whoever is watching, please answer the question so that it will be more interactive. And you can give me the energy by giving the answers. Right. The question is, which of the following sentences can be generated by this grammar? Now, look at, these are the sentences. S tends to B, C, C, D, D. Means S is deriving this terminal. S tends to B, A. This is a production suitable. This is a production suitable. And next, with A, I have to get C. To get A, to get C using A, actually this is a small c, and It is a small c. And here small c, capital A. So BC is derived. With A again I wanted C. So means C, capital A. With capital A I have to get D. Yes, D. But actually one more D is left. That is not derived. Incorrect. Means B, C, C, D is okay. But one more D, not correct. S tends to, because A wanted AS. A derived. With S I wanted B means BA, derived. With A I wanted B, with A I wanted B, but A is not deriving B, it is deriving D or C, so it is incorrect. And question option C, S tends to, because A wanted, S tends to AS, we got A. Because B I wanted, I can go with BA, happy. With A I wanted C, go with CA, happy, getting C. And next with A I wanted A, but with A is not possible. So option C is wrong. Look for this, option D. S tends to AS. A we got it. And with S I wanted B, so we have to go with BA. Okay, happy, BA. And with A I wanted C. Okay, that is CA, correct, I got C. And finally with A I wanted to have D, that D is possible because we have a production. So means D is the string derived using this grammar. See how simple these questions are, that is very easy. Look at this question. It is slightly interesting. What is the number of steps required to derive the string? Actually, this string is for well-formedness of parentheses. Open, close, and this is open, close, and this is open, close. For the following grammar. This is an ISRO 2014 question. Which production we have to apply? S tends to SS. What is the question actually? The number of steps. This is the first step. Or else instead of drawing the tree, I can make it draw the derivation steps, because the question is about number of steps now. So S tends to SS. It is a first step. So I may use leftmost derivation. What is the string I have to derive? This one. That string I have to derive means S is to be replaced with open, S, close, and S. Because look at, everything is in single open and close. So one more S is there which is of no use. So I can replace this S, here I am using rightmost non-terminal, to be null. This is a second step and this is a third step. Now I got this open, this close. Now inside it we have one open close, one open close. So means that S I can replace with SS. This is a fourth one. And each S to be replaced with open S close, open S close. So what we are getting? This open, this close, this open, this close. So what is left finally? This open, close, open, close. So means this S, okay, first I will make this S to be epsilon, so that it is finished. Open, open, S, close, open, close, close. Now what is finally left? Two open closes, two parentheses using this S. So means we have to go with one more step. Open, open, that S is going to be replaced with SS. Close, open, close, close. It is a seventh step. Again each S should derive one open close. Okay. So because steps is asked, don't write in a single step. Don't write in a single step. Now this S is going to be epsilon. Open, 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 close, S, close, open, close, close. This is a ninth step. Last this one, that S is to be replaced with open, 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 close. That S is open as close, open, close, close. Right? That S is replaced with open as close again. And this is a 10th step. This is a 10th step. right? And this S is going to be replaced with epsilon. Open, 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 close, open, close, open, close, close, right? And this is the 11th step. So anything is missed? Yeah, I think we have missed this close parenthesis, right? Now we got the required thing. We got the required thing. In how many steps? In 11 steps. Actually 11 steps are not there. Just check it out. Any mistake happen. And if no mistakes, I can say the more closest answer is option A. So A is the answer. Just check it out. So first step SS, but here look at this well-formedness of parentheses are important. So this is one step, second step, and this is removed. And after this, I got open S close, and open S close, S is replaced with SS. So we got open close, these two we got it. And this each S is one open S close, one open S close, one open S close. This one, this one, this one, this one. And this is epsilon, one step, and this S is, this is S is again SS, and each S is open S close, this S is open S close. Open S close, and next step S is epsilon, that S is open S close, next step is epsilon. So here I am getting 11, but 11 is not in the options, so the closest option is, I can say option 10. You also check once again. Actually, why I am asking you to check once again now? In ISRO, there are certain questions which are very ambiguous questions. Very ambiguous question means no option is correctly matching. So you can see certain questions also. There are so many ambiguous questions are there, but we can't do anything with that ambiguous questions because ISRO is not responding for the users' queries, right? So I may be wrong that ISRO is responding or not, but the point is very clear. There are certain ambiguous questions are there, and in some times no option is matching. So I recommend you please try this question one more time in your style and check it, is the 10 is the answer or not, or else 12 is the answer, because it is very close to 10 and 12 because I got 11. So if any step is missing, you can check it out, okay? Right. It is a ISRO 2015 question. Which of the following is a top-down parser? So what are the top-down parsers? Recursive descent parser is a top-down parser. Shift reduce, bottom-up parsers. SLR parser, bottom-up parser. LRF key, bottom-up parsers. So what is a top-down parser? Recursive descent parser. See, if you know these basics, shift reduce parsing is bottom-up parsing. If you know these basics, answering the question is easy. See, recursive descent parser is a top-down parser. A top-down parser generates leftmost derivation. YAKI stands for yet another compiler, yet another compiler. See, all are the basics questions. These are all the basics questions. Very basic questions were there. Here you can see substitution of names. Just now I was telling about the ambiguous questions. Here you look at substitution of values for the names. Values for the names means program names, program variables. This is called substituting values for the program variables is done. So wherever a variable is there and that is to be replaced with its value, this is called variable propagation. It is called variable propagation, or we call constant propagation. So actually in variable propagation, we also called copy propagation. In copy propagation, A equal to B is a copy statement and copies are propagated. Suppose we have A equal to 5, wherever A is there, A replaced with 5. So this is called A is 5 and 5 is a constant value, assuming it is const int A, it is a constant value, and constant value, it is meaning that during the program execution, the value of A is not changing. Because it is not changing, wherever A is found, that is going to be replaced with 5. This is called constant propagation. Constant propagation. Do you have this option in the previous ISRO question? Do you have this option, constant propagation? Local optimization, loop optimization, constant folding, strength reduction. We don't have constant propagation, but in the key it is given constant folding. But what is the meaning of constant folding? Suppose A equal 2 plus 3. Constant folding is nothing but, this is a constant expression, 2 plus 3. The evaluation of this 2 plus 3 you do before or after. Before the compilation, after the compilation, while execution also you do it. The result of 2 plus 3 is always 5. Correct or not? Yes. So means this is a constant expression and its final value is replaced, is called constant folding. It is called constant folding. But instead of constant folding, he could have given local optimization. Okay, happy. But constant propagation is also not local optimization, because constant propagation can be done locally as well as globally also. That is also not proper options. See, no option is proper. Actually, the option should be constant propagation, but it's not there. It is a ISRO 2009 question. That's what I told you. Ambiguous questions are there. Be careful with an ambiguous question, which is very close to that. You can put your answers. And these are all the questions. Okay, these are all the questions from ISRO, from the ISRO previous year questions. And just I wanted to conclude this today's session saying that most of the previous ISRO questions are from the GATE. Some of the examples have shown you. And some of the questions are ambiguous questions, but that ambiguous questions, don't ignore it. Just try to look the nearest one, which is possible that you can choose that options. I have shown you some ambiguous questions also. With this, I wanted to say only one thing. While suppose you are preparing for ISRO, I suggested you to solve all the PYQs of GATE, especially all the PYQs of GATE 1 mark questions. That is important. Don't worry about GATE 2 marks questions, because GATE 2 marks questions are rarely asked in ISRO papers, mostly 1 mark questions. That is important. And here, just I wanted to conclude the session by saying, when you are preparing ISRO, so what is the contribution from the ACE Academy? So ACE is offering the self-paced program. ACE Online is offering a self-paced program. The self-paced program is having pre-recorded lectures. All the lectures are already recorded, which are available in the ACE Online app. You can download the ACE Online app by scanning the QR code, or you can get this app from Google Play Store or Apple iStore. And we have a quick review of the pre-recorded lectures. It is not the booklet where you can see the previous year question and just an answer. Here, these are the pre-recorded video lectures, and where we have explained every question of examination. I'm not just saying GATE and ISRO, any competitive exam, it is very GATE and ISRO PYQ's pre-recorded lectures is for the very nominal fee of 3,000 rupees to help the student community. Right? And और एक अच्छी बात है नॉर्थ इंडियन लोगों के लिए, एस ने ऑफर कर रहा है प्री रिकॉर्डेड लेक्चर्स हिंदी भाषा में, क्योंकि अगर आपको पढ़ाई करना है, पढ़ाई करो हिंदी में, हमारा भाषा में, अपनी भाषा में, ताकि आपका सारे सब्जेक्ट्स, सारी टॉपिक्स, सारा कॉन्सेप्ट्स आपको इजी और आसानी में समझ में आएगा. इसलिए एस ने लॉन्च किया है एक्सक्लूसिवली गेट कोर्सेस को अपनी मन की बोली हिंदी भाषा में, क्योंकि इसका यही मानना है, पढ़ाई करो तो दिल से करो. राइट? एंड वन मोर लास्ट थिंग, एस had computer science ISRO booklet, which has all the previous year questions of ISRO, subject wise, topic wise, subtopic wise, which are segregated and properly arranged so that your preparation becomes easy, which is available in Amazon, Flipkart, and aceengineeringpublications.com website. Just go there and purchase it, and this will be definitely helpful for you. And with this, just I wanted to conclude it. And before I conclude, just I wanted to say only one thing. जीत और हार तो परिणाम है, कोशिश करना हमारा काम है, कोशिश करते ही रहिए. Don't worry about the result. Do your best. If you give your best, automatically you are going to achieve the goal. So one day or other day, you may defeat all the odds and you are going to be the king. So I'm wishing you all the best, wishing you good luck. Signing off, always yours, Ramesh Masuna, sir. Thank you. ఏం వింటున్నారు మీరు? మీరేం వింటున్నారు? యూట్యూబ్ ప్లే చేసారు. అయిపోయే టైంలో వినొద్దు కదా అట్లా యూట్యూబ్. ఇంతసేపు విన్నారు, ఓకే.
లేదు మీరు బ్రేక్ నేను ఆల్రెడీ అడిగితే బ్రేక్ ఏమి సార్ కంటిన్యూ చేస్తారంటే అని చెప్పేసి అన్నాను. అట్లా అని చెప్పేసి
కంటిన్యూ ఎప్పటి వరకు? 8 వరకే కదా?
అవును సార్.
ఇప్పుడు ఎంత అయింది? మీరు లాస్ట్ మినిట్లో ఉండాలి, అలర్ట్గా ఉండాలి. అది ఎఫెక్ట్ కనబడుతుంది అనమాట. మీ పేరేది ఏంటి?
ప్రసాద్ సార్.
ప్రసాద్ కలిసారు ఇంతకుముందు ఒకసారి?
అవును సార్, ఇంతకుముందుకు వచ్చి
ఒకసారి రికార్డింగ్ చేస్తాను కదా?
చూసి వెళ్ళిపోయారు సార్.
చూసి వెళ్ళిపోయారా?
చూసి వెళ్ళిపోయారు.
రికార్డింగ్ లేదు మీరు?
లేదు సార్.
సరే సరే, ఓకే.
ఓకే సార్, థ్యాంక్ యూ.
ఎవరు చెప్పారు? వెంకట్ ఫోన్ చేశాడా?
ప్రకాష్ చేసినాడా సార్?
ప్రకాష్ చేశాడా?
నేను టైం చూడలేదు సార్, టైం ఉన్నాయి అనుకున్నాను అట్లని.
పర్లేదు పర్లేదు, చూసుకోవాలి. అది నేను ఏమంటున్నాను, చూసుకోవాలి. చూసుకోకపోతే ఏంటంటే అది ఏదో నేను చెప్పేసి ఆపు ఆపు అన్నట్టు ఉంటుంది, గలీజ్గా ఉంటుంది.
ఇప్పుడు లైవ్ ప్లే చేసిన యూట్యూబ్లో లైవ్ ప్లే అయితే లేదు కదా. ఓకే, అది యూట్యూబ్లో స్ట్రీమింగ్ అవుతుంది, అది తిరుగుతూ ఉంది. అందుకని సార్ చెప్పేంత అంటే మొత్తం స్టార్ ఇంకా కొద్దిగా చెప్తుంటేనే ఎండింగ్లోనే క్లోజ్ అయిపోయింది. నో డౌట్ అని కాదు సార్ది, ఏమంటారు, స్టాప్ అయ్యి రౌండ్ తిరుగుతూ ఉంది అంతే. కొట్టిన ఎప్పుడు వచ్చింది ఇండస్ట్రీ అని ఇక్కడ. ఇప్పుడు లైవ్ వస్తుంది. ఎండ్ కొట్టేశానా? అయిపోయింది, 8 అయిందిగా. రైట్, అంతేనా? ఇంకేమైనా అప్లోడ్ చేసేటి ఏం లేవుగా.